Which test automation frameworks are you familiar with or have experience using? In my experience, I've worked with various test automation frameworks such as Selenium WebDriver with TestNG for web applications and Appium for mobile applications. Additionally, I have familiarity with BDD frameworks like Cucumber and SpecFlow, which promote collaboration between technical and non-technical team members. These frameworks not only enhance test efficiency but also provide clear reporting mechanism. How to create test cases for automated tests. When creating test cases for automated tests, I follow a systematic approach. I begin by identifying test scenarios, outlining preconditions, and determining expected outcomes. I ensure that test cases are modular and independent to facilitate easy maintenance. Clear and concise documentation is crucial, including information on data inputs, expected results, and any specific conditions or dependencies. How many test cases can be automated per day? The number of test cases that can be automated per day depends on factors such as test complexity, application stability, and the proficiency of the automation engineer. On average, I aim for quality over quantity, automating around 5 to 10 test cases per day. Prioritizing critical and frequently executed test scenarios ensures a focus on high-impact areas. How can the speed of automation testing be improved? Automation testing speed can be improved by optimizing test scripts for efficiency, parallelizing test execution, and employing techniques like headless testing. Additionally, minimizing unnecessary waits, using appropriate timeouts, and leveraging techniques such as test data optimization contribute to faster execution. Continuous performance monitoring and periodic script reviews help identify bottlenecks and areas for improvement. How would you select a test case for automation? Test cases suitable for automation are those that are repetitive, time-consuming, and stable. I prioritize test cases with a high probability of regression, covering critical functionalities. Boundary tests, data-driven scenarios, and those requiring multiple configurations are also strong candidates for automation. Regularly reassessing and updating the automation suite ensures its relevance. Explain how you incorporate JavaScript files in your tests. Integrating JavaScript files into tests can be achieved using tools like Protractor or Cypress for web applications. I include JavaScript functions within test scripts to perform specific actions, manipulate the DOM, or handle asynchronous operations. This approach enhances test capabilities and allows for seamless integration with the application's front-end functionalities. In what situations would you opt to use the Gherkin language? Gherkin language is valuable in scenarios where collaboration between technical and non-technical stakeholders is essential. I use Gherkin syntax with tools like Cucumber to write human-readable, business-oriented scenarios. This approach fosters better communication, ensuring that both technical and non-technical team members have a shared understanding of the application's behavior. What automation testing tool was utilized in your previous project? In my previous project, we utilized Selenium WebDriver with Java for web application testing. The choice was based on its robust community support, cross-browser compatibility, and the ability to integrate with various testing frameworks like TestNG. This combination allowed us to create a scalable and maintainable automation framework. For which types of tests would you choose not to use automation? While automation is beneficial for repetitive and time-consuming tasks, it may not be suitable for exploratory testing, usability testing, or scenarios where the application undergoes frequent changes. Additionally, for small-scale projects with limited resources, the overhead of automation setup might outweigh the benefits. How do you handle synchronization issues in automated tests? Synchronization issues in automated tests are addressed by incorporating implicit and explicit waits strategically. I use explicit waits for specific elements to be present or clickable and implicit waits to handle general delays. Additionally, leveraging smart waits, such as dynamic waits based on element visibility or custom conditions, helps mitigate synchronization challenges and enhances the reliability of automated tests. Regularly reviewing and updating waits based on application behavior changes is crucial for maintaining synchronization. Explain the importance of using POM in Selenium. The page object model, POM, is crucial in Selenium automation for enhancing maintainability and reusability of code. It introduces a design pattern where each web page is represented by a corresponding Java class, encapsulating the page's elements and actions. This separation of concerns makes the code modular, simplifies updates, and minimizes redundancy. When a web page undergoes changes, updating the related class is much more efficient than modifying scattered code throughout the test suite. POM fosters collaboration between developers and testers, as developers can work on the page classes while testers focus on creating and maintaining the test scripts. Explain the concept of cross-browser testing. Why is it important? Cross-browser testing involves validating that a web application functions correctly across different web browsers and their versions. This is crucial because users access applications through various browsers, and each browser may interpret code differently. Cross-browser testing helps identify and address compatibility issues, ensuring a consistent user experience. It also enhances application reliability and accessibility. Automated cross-browser testing frameworks, such as Selenium, allow for efficient execution of test scripts across multiple browsers, streamlining the validation process and reducing the risk of browser-specific defects. Is it possible to attain full automation coverage of the testing process? Achieving full automation coverage is challenging and often impractical. While automation is powerful for regression and repetitive tests, it may not be suitable for exploratory testing or scenarios with frequent changes. Some aspects, like usability and visual testing, are better addressed through manual testing. A balanced approach, combining automated and manual testing based on the testing needs and project constraints, is often the most effective strategy. Out of 500 test cases, only 100 passed, and the rest failed. How would you rerun the failed test cases in an automated testing scenario? In an automated testing scenario where 100 out of 500 test cases failed, I would first analyze the test failure reports to identify the root causes. Once the issues are understood and addressed, I would selectively rerun the failed test cases using automation test scripts. Continuous integration tools like Jenkins can be configured to rerun specific failed test cases automatically, providing quick feedback on whether the issues have been resolved. In the context of manual testing, how would you transition from manual to automated testing? Transitioning from manual to automated testing involves a strategic approach. Begin by identifying repetitive and time-consuming manual test cases suitable for automation. Develop a robust automation framework, selecting appropriate tools and technologies. Gradually automate high-priority test cases while maintaining a balance with manual testing for exploratory and ad hoc scenarios. What criteria do you consider when selecting tools for automation testing? When selecting automation testing tools, key criteria include compatibility with the application and technology stack, community support, ease of integration with other tools, scalability, and the ability to generate comprehensive test reports. The tool should align with the project requirements and testing objectives. Additionally, considering factors like licensing costs, maintenance efforts, and available documentation ensures a well-informed decision. Discuss the significance of using the try, catch, and finally blocks in Java when designing robust automation test scripts. The try, catch, and finally blocks in Java are essential for designing robust automation test scripts. The try block encloses the code that may throw exceptions, and the catch block handles those exceptions, preventing script failure. The finally block ensures that certain actions, such as closing resources or releasing connections, are executed regardless of whether an exception occurs. This robust exception handling improves script reliability, facilitates debugging, and ensures graceful recovery from unexpected issues during test execution. Please refer to our previous new videos for more testing interview questions with sample answers. All links in video description. Explain the concepts of implicit wait and explicit wait in Selenium for handling synchronization in automated testing. Implicit wait and explicit wait are synchronization strategies in Selenium. Implicit wait sets a global timeout for the entire script, allowing the driver to wait for a specified time before throwing an exception if an element is not immediately available. Explicit wait, on the other hand, applies to specific elements, allowing the script to pause until the element becomes visible or meets a certain condition. Both techniques are crucial for handling synchronization issues in automated testing. ensuring that the script executes at the right pace and reducing the likelihood of false negatives due to timing mismatches. How does exception handling work in Java, and why is it crucial in automation testing scripts? Exception handling in Java is critical for managing unexpected situations that may arise during test script execution. By using try, catch, and finally blocks, automation scripts can gracefully handle errors, log relevant information, and proceed with the remaining steps or cleanup activities. Exception handling improves script stability, provides better insights into the root cause of failures, and enhances the overall robustness of the automation framework. How do you parameterize your test scripts in TestNG using Java, and why is it important for automation testing? Parameterization in TestNG allows the execution of the same test method with different sets of data. In Java, parameters can be defined in TestNG XML files or through data provider annotations. This practice is essential for automation testing as it enables the creation of data-driven tests. Parameterizing test scripts enhances test coverage, promotes reusability, and simplifies the maintenance of test suites. It also facilitates running tests with various input values, validating the application's behavior under different scenarios, and supporting the principles of agile and continuous testing. What is difference between find element and find elements in Selenium? In Selenium using Java, find element is used to locate and return the first matching web element on a web page. It returns a single web element instance or throws a no such element exception if no matching element is found. On the other hand, find elements returns a list of all matching web elements or an empty list if none are found. This method is beneficial when dealing with multiple elements, and it eliminates the need to handle exceptions if no elements are present. Explain the use of annotations in TestNG. Can you name a few important annotations and their purposes? Annotations in TestNG play a crucial role in defining the test execution flow and configuring test methods. Some important annotations include: @test identifies a method as a test method. @beforetest and @aftertest define setup and teardown methods that run before and after a test suite. @before method and @after method specify methods that run before and after each test method. @data provider supplies test data to test methods. @parameters passes parameters to test methods. Annotations help structure test execution, manage dependencies, and enable parallel execution, contributing to a more organized and flexible test framework. What is difference between driver.close and driver.quit in Selenium? In Selenium, driver.close is used to close the current browser window or tab, while driver.quit closes the entire browser session, terminating all windows and tabs opened by the WebDriver. Using driver.quit is recommended for proper cleanup, as it releases resources associated with the WebDriver instance, ensuring a clean exit. Failure to use quit may leave background processes running, leading to memory leaks and impacting system performance. How do you handle dynamic elements in Selenium? Dynamic elements, whose attributes may change dynamically, require special handling. Techniques include using partial attributes, such as substring matching, or employing dynamic XPath or CSS selectors. WebDriver wait with expected conditions is useful for waiting until dynamic elements become visible or meet specific conditions. Regularly updating locators based on changes in the element's attributes or structure is crucial for maintaining automation scripts in the face of dynamic behavior. Explain the concept of implicit and explicit waits in Selenium. When would you use each? Implicit wait, it sets a global timeout for the WebDriver to wait for an element to be present before throwing an exception. It is applied throughout the script and can reduce the likelihood of synchronization issues. However, it might introduce unnecessary delays. Explicit wait, it is more specific, allowing the script to wait for a particular condition on a specific element. It is used with WebDriver wait and expected conditions, providing more control and precision. Explicit waits are preferable when waiting for dynamic elements or specific conditions to be met. In Jira, how do you update the status of an issue? Is it done manually or through automation testing? Updating the status of an issue in Jira can be done manually by navigating to the issue and changing its status through the user interface. Alternatively, automation testing can be employed using Jira's REST API, where scripts or tools interact programmatically with Jira to update issue statuses based on predefined conditions or test results. What is the difference between functional testing and regression testing? Functional testing focuses on verifying that the application functions as intended, ensuring each feature behaves correctly according to specified requirements. It is typically done during the development phase to validate newly implemented functionality. Regression testing involves testing the entire application or specific functionalities after changes are made to ensure that existing features still work as expected. It helps identify unintended side effects and ensures that new developments do not break existing functionality. How would you handle a situation where a test case is failing, but the application functionality has not changed? If a test case is failing, but there have been no changes in the application, I would first review the test script and test data for potential issues. It's essential to check for environmental changes, such as browser versions or configurations. Additionally, I would rerun the failed test in isolation to ensure it consistently fails. If the failure persists, a deeper investigation into the test logic, assertions, or potential intermittent issues would be necessary. On a web page with 100 links, how would you determine the count of links, and which locator would you use to find their XPaths? To determine the count of links on a web page with Selenium, we would use the findElements method with a tag selector, representing links. The XPath locator would be something like to select all anchor elements. The count of elements returned by findElements would provide the total number of links on the page. How would you approach automating the login functionality of a web application using Selenium? What are the key test scenarios you would consider? To automate login functionality, I would create Selenium test scripts using a page object model, POM, for maintainability. Key test scenarios would include valid login with correct credentials, invalid login with incorrect username or password, checking for proper error messages on failed login attempts, verifying the redirection to the correct landing page after successful login, handling scenarios like account lockouts or password recovery. By addressing these scenarios, the automated tests ensure the robustness and reliability of the login functionality across different scenarios. Your application needs to be tested on multiple browsers, e.g., Chrome, Firefox, and Safari. How would you approach cross-browser testing, and what challenges might you anticipate? Cross-browser testing is crucial for ensuring that an application functions correctly on various browsers. To approach this, I would create Selenium scripts using a framework like TestNG and execute tests on each target browser, such as Chrome, Firefox, and Safari. Selenium's WebDriver supports multiple browser drivers for seamless cross-browser testing. Challenges: browser-specific behaviors. Different browsers may interpret elements or execute JavaScript differently, leading to inconsistencies. Synchronization issues. Each browser may have varying loading times, requiring careful consideration of implicit and explicit weights. Browser version compatibility. Ensuring compatibility across different versions of the same browser is essential. Handling browser-specific pop-ups. Some browsers may display unique pop-ups or security dialogues that need to be addressed in the scripts. To mitigate these challenges, would leverage capabilities like conditional statements for browser-specific handling, use WebDriver weight for synchronization, and maintain a matrix of supported browser versions. Your team is adopting a continuous integration approach, and you need to integrate your Selenium tests with a CI tool, e.g., Jenkins. How would you set up and manage the automated test execution in a CI environment? Integrating Selenium tests with Jenkins for continuous integration involves the following steps. Version control integration. Store the automation code in a version control system, e.g., Git. Configure Jenkins job. Set up a Jenkins job to pull the latest code from the repository. Install necessary dependencies. Ensure that the required tools, drivers, and browsers are installed on the Jenkins machine. Execute Selenium tests. Use build scripts or Maven goals to trigger the execution of Selenium tests. Generate reports. Integrate reporting tools like TestNG or Allure to provide detailed test reports. Trigger on code commits. Configure Jenkins to trigger the job automatically upon code commits. Regularly updating dependencies and maintaining a clean test environment in Jenkins are essential for consistent test execution. While executing your test suite, you encounter an unexpected pop-up or error message. How would you handle such unexpected situations in your Selenium scripts? Unexpected pop-ups or error messages can be handled using Selenium's alert interface for pop-ups and try-catch blocks for error messages. I would use the driver.switchTo.alert method to switch focus to an alert and perform actions like accepting, dismissing, or retrieving text from the alert. For unexpected error messages, would incorporate try-catch blocks to gracefully handle exceptions, log relevant information, and take corrective actions if necessary. Suppose you need to perform the same test scenario with multiple sets of input data. How would you implement data-driven testing in your automation framework? For data-driven testing in Selenium, would use TestNG's data provider or incorporate external data sources like Excel or CSV files. Each set of test data would be associated with a test method, and the data provider would feed the data into the tests. This approach allows for the execution of the same test logic with multiple data sets, enhancing test coverage and promoting reusability. It also simplifies maintenance as changes to test data can be made outside the test scripts. Perform a Google search and provide the XPath for the search bar on the Google homepage in the context of automation testing. XPath for Google search bar in automation testing. The XPath for the Google search bar on the homepage can be obtained using browser developer tools. In this case, the XPath might be input @name equals Q. This XPath selects the input element with the attribute name equals Q, representing the search bar.